Thank you for joining us for today's webinar, The Chemistry of Tile Grouts, Caulks, and Sealers. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to MAPEIDigital@mapei.com. We also invite you to visit the Tile and Stone Installation Systems page on our website, www.mapei.com, which contains the latest industry information, including helpful videos and downloads. Now, without further delay, I'd like to introduce today's speaker, David Mowry. David joined MAPEI in 2002 as Research and Development Group Leader. After 10 years in R&D, he accepted a position in MAPEI's Strategic Marketing Department as Business Manager. He's responsible for MAPEI North America's Grout, Caulk, and Care and Maintenance product lines. He's also responsible for new product launches within these same product categories. And he ensures that products being sold to both MAPEI's commercial and retail sales channels are meeting the expectations of our diverse and expanding customer base. This makes him uniquely positioned to speak to today's topic. So with that, I welcome him to the microphone. David, the floor is yours.
Well, thank you, Jen. Thank you for your introduction, Jennifer. I appreciate that. Good afternoon to all of you. Thank you for taking the time to participate in this webinar. As always, we want to thank our MAPEI distributors for their loyalty to the MAPEI brand. We also want to thank the contractors and installers who use our products on a daily basis. Our presentation today, as Jennifer mentioned, is the chemistry behind Caulks, Grouts, Caulks, and Sealers. So let's get started. So the key objectives this morning, or this afternoon, whichever time zone you're on, is to do a Cement Chemistry 101 review. There is a direct link between definitely our cementitious grouts and cement chemistry, so it's good to have a basic background in cement chemistry when you start discussing powder grouts for sure. Caulk and grout chemistry and their performance characteristics will be discussed next. Then we'll move on to tile industry standards, how they can assist you in your grout and caulk selections. And finally, we'll finish up with tile, stone, grout, and care and maintenance chemistry and a product overview. So a lot of areas to cover here. Some background words just that I'll be using throughout the presentation. The first 6 there on the list are all part of the Cement Chemistry 101. Starting with the first 3, lime, limestone, and aggregates. They're the core ingredients to the manufacturing of cement. You'll see that as we go through the next couple slides. The acronyms OPC, CAC, and ACM will be discussed. We'll contrast OPCs to CACs and make sure you follow that acronym because there's a big difference between those two. ACMs actually overlaps to CACs. CAC, or calcium aluminate cement, is one of several different alternative cement mixtures, or ACMs. Working time is specific to grout. This amount of time available before the product begins to set up and become unstable or unusable. So that's an important point we'll be using, our term. RTU, it can be expressed as ready to use. That's the direct acronym for RTU. It's also referred to as a single component grout or a premixed grout. That's the old terminology from about a decade ago with the first generation of that product. Effervescence, most of us have heard of that. That's the white powdery deposit. We'll have some video, some actual visuals of that later on in the presentation. It's the salt that migrates. It is specific just to standard cementitious grouts and not to epoxies or RTU. ISO, ANSI, and TCNA. I'll be discussing the industry standards. These are the people that set these standards. And next we'll talk about sealants versus sealers. There is a distinct difference. Those words are tongue twisters at times, but the sealants are the caulks, or otherwise called caulks, which are used to fill gaps, cracks, and joints throughout the tile insulation, or expansion joints as an example. Sealers, we're referring to penetrating sealers or topical sealers or enhancing sealers. There's 3 different types, and they provide a stain and chemical resistance to natural stone, it's very important to have. Chemistry 101, take a look at that. I mean, what we see here in this graphic is a rotary kiln. That's the magic that happens, where the magic actually happens, if you will, with the rotary kiln. That's essentially, it's a big heater that's under pressure and sometimes under vacuum to actually decompose calcium carbonate, which is what you see here, which is limestone, to perform. And what's that do when it does that? That calcination is the terminology we use for that. It's actually taking calcium oxide and carbon dioxide in order to create the cement. So it's that degradation of or decomposition of calcium carbonate creates CaO, which is calcium oxide, and carbon dioxide. Not the best thing in the world there, but we'll talk more about that. Cement, it's and the clinker, as we go down, how's it actually produced and what it is. The three stages are simply, if you add the raw materials of limestone and clays with water, nothing's really going to happen. But if you impart heat to that kiln and upwards of 1450 C in temperature, and that creates what's referred to, or it calls as a reaction of the calcium in the limestone to combine with the silicons in the clays. And what that does is create silicates. And so the 4 bullets below that are versions of different silicates. Typically, we abbreviate those as C3S, C2S, C3A, which is the aluminate version of the silicate. And what comes out of all that is a clinker, which is actually the intermediate product from the calcinization process. That final step, the third phase of this, is they take that that clinker, which is a larger particle size, and grind it into a fine powder using a cement mill and with adding gypsum to create the cement itself. That's the brief overview. You could get to a lot more detail on it, but it's easy to see it as just a 1 or 2, 3-step process. The next screen shows you the 8 key raw materials in cement manufacturing. The key ones to discuss here are pretty much lime and silica. They're obviously the largest contributors from a percent composition. And we sort of saw that in the clinker example I gave you, or the breakdown I gave you before. Alumina is also an important raw material in the formulation. And we'll take a closer look at each one of those, but there's a total of 8 actual materials in there. Functions of some of these key raw materials, just sticking with just the key ones here. Lime is actually used in that formulation to form the silicates and aluminum calcium. It's very important to get the right quantity of lime. If you get too much, it reduces strength. If you get too little, it can actually compromise integrity. So that there's a issue with getting just the right balance of lime into the kiln. In part strength is the silica. The alumina in there is a quick setting properties. When we talk about alternative cement mixtures with calcium aluminate, you'll see that the alumina connection with that as well from a chemistry standpoint. Magnesium will reduce cement strength if it's added in excess, so we got to be careful about that. And the sulfates are just slows down or retards the set time. If we compare OPCs to CACs, I mean, they're definitely a different class of cement. They're both in the powder cement category, but one's considered a ordinary Portland cement and one's considered more of a high performance product, which is a CAC. So if you look at the bullet points that point out the advantages of CAC, it starts with, it's got a far greater alumina standpoint, or alumina content versus silica. It has much more of a compact molecular structure than OPC, so it's more tightly bond, which improves the water absorption, lowers the water absorption. And significantly higher early strength development. And you'll see that if you've ever mixed a bag of our Ultracolor Plus FA, it actually imparts a heat of hydration, which is in the next bullet down. The bucket actually gets hot as you work through the process because it's sort of it's a reaction of heat of hydration that's causing that. It does not have any calcium salts, so no calcium or calcium hydroxide, which is the source of effervescence. And another good point about CACs is it does have a lower or lesser carbon footprint than OPCs. The chemical properties OPC versus CAC. If you look at the columns here, you get silicates on the left and you got aluminates on the right in the table. And if you look down the ordinary Portland cement column, you see the high levels of calcium silicates, which are on the left as C3, C2, 3, the first two in the table, the first two rows. And then if you get down the aluminates, you see a much larger percentage of aluminum silicates in the formulation. The graphic on the right shows you does a direct comparison of traditional Portland cement with the calcium hydroxide crystals and a microscopic look of it. If you look down below, it's our Ultracolor Plus, which again is a CAC chemistry, which has none of that the calcium hydroxide crystals. So it's effervescence free essentially. The carbon footprint, I mentioned a minute ago that OPCs have a high level of contribution to CO2 due that as it gets processed in the kiln. And if you look at on a pie chart basis, it's 8% of total CO2 emissions comes from the concrete, or actually manufacturing of cement. And that doesn't include the traffic of cement to a job site or whatever, to a plant for processing. Alternative cement mixtures, ACMs, have a smaller footprint, and I think that's sort of the direction we'll see in the future is more use of that just for that reason alone, or even blends with CAC with OPC. Grout chemistry and performance attributes. There's 5 different categories we will discuss in some detail now, and starting with standard cement grouts. That's your OPC grouts. The high performance cement grouts, that's your CAC grouts, your calcium aluminate grouts, more high performance. The premix or ready to use grouts is another category we'll discuss. And then the final 2 will be the epoxy non-industrial versus industrial grade and where to use those. Cement powder grout's basic chemical composition, it's either OPC or CAC as a binder. The fillers are calcium carbonate, limestone, clays, that type of filler. The aggregates are either a fine or coarse aggregate. It varies in particle size. Our FA grouts get a very fine aggregate in terms of particle size. The fumed silica is also a typical aggregate used in the formulation of cement powder grouts. And then there are all different specialty of additives. And these vary from manufacturer to manufacturer how they utilize these. But they can be accelerators, retarders, dispersants, whatever the case may be. And obviously, as you see in the graphic to the right, that's the pigment range. Typically not so vibrant with grouts, but the inorganic oxides are typically used along with TiO2 as the pigments. And there is always some antimicrobial that's used for mold and mildew resistance as well as part of the formulation. So a closer look at Portland cements. We'll get into more detail about the ANSI specs later on, but it conforms with ANSI A118.6 as well as ISO 13007. The suffix on there is important because that represents different things you'll see in the screen that ISO uses later on. I'll show you the details of that. ISO uses to define the grout category. Hydraulic cure is the mechanism for curing. So when the cementitious powder reacts with the mixed water, it creates a hydraulic reaction within the matrix. If you look at some installation variables, the Portland cement probably has more than any because it's at the mercy of temperature of the mixed water, temperature of the grout powder, which you want to keep it ambient conditions 24 hours before you use it. The working time it can be compromised, especially in high heat and humidity installations. Not all grouting is done at room temperature. Product mixing is important. You have to make sure you mix it for the adequate amount of time. In this case, you actually do a slake, which I didn't have on a list, but along with that product mixing, there's a slake time, which allows the hydraulic reaction to cure to a level before you do a final mix. The temperature of the wash water is also important. And then what happens if any of these are abused? Like overwashing, you can lead to effervescence, and overwashing can also lead to shading or mottling. That's during the cleaning process. High performance, a lot less installation variables than the previous product we looked at, the OPCs. It does now conform with 118.7, which is a higher level specification by ANSI, and it has the CG2 WAF suffix to the ISO spec, which F is for fast setting. The curing process is the same as the OPCs, but it typically has a rapid setting function, which is the F or the fast setting in the ISO spec. That allows for foot traffic in 3 to 4 hours, and it traditionally is referred to as effervescence-free grout. A lot less installation variables, as you can see there. It's good to compare what the price is or the impact on a market price. So just if you look at the column cost per unit, estimated market price, third from the right, and you look down for there at on a 1,000 square foot job site, you're looking at $27 versus $17 for pricing differential between using a original Portland cement OPC versus a high performance. That's less than a little bit more actually than 3 cents per square foot. That's very, very doable, and to get rid of a lot of headaches like effervescence and improve stain resistance and more color consistency. It's worth the effort or the expense. RTU grouts, switching to RTU, ready to use grouts. They include a binder and a filler and an aggregate. The binder is typically one of 3 different types of binders. You have an acrylic latex, a urethane, or a hybrid, which is typically a combination of latex and urethane. But these are the typical binders used. It's a water-based product. It's not 100% solids, as you can see there with 75%. Fillers are typically calcium carbonate or limestone. And the aggregate, again, is from fine to coarse with possibly a fumed silica in there. Everything else is similar to what we see with the other grouts as well, in terms of the other attributes or formula composition. Ready-to-use grouts don't officially have a industry standard right now. It doesn't have an ANSI standard. That's work in progress by a subcommittee of the TCNA group. So we hope to have that soon, but at this point in time, there's no official standard. What some manufacturers of grouts have done is utilize the existing standards and actually test a ready-to-use grout, in our case, Flex Color CQ, under the ANSI spec of 0.3 and ANSI spec of 0.6 on some tests, for instance, compressive and a few others that were, and water absorption, a few others that were able to achieve specification on that. There has been a big evolution in the last, say, 5 years in the chemistry technology that's being used in RTU grouts. It's a much higher performance product now than it used to be. And we've seen that in our cells. It's very popular at this point. The curing process is different than hydraulic. It's by dehydration. So as it loses its water, it actually cures out. Typically, you can have foot traffic in 24 hours. You won't want to expose it to intermittent water for 72 hours. But you look at the variables below, they're again a lot less than what we had before. We use a wash as you go approach to cleaning, not what we use with cementitious grouts, so it's quite different, or epoxy grouts, so it's quite different than either one of those two. Epoxy grouts are formulated with a resin and a hardener. The resin is typically a bisphenol or BPA epoxy resin. Epoxy grouts can be either water-based or 100% solids. 100% solids is what MAPEI epoxy grouts are formulated with. Not all of them on the market at all, but it guarantees a more robust epoxy grout when you have 100% solids. The hardener is an amine system or amine chemistry, so it's the part 2 of the epoxy resin mix. And the aggregate's usually separated out as a part 3, but not always. So it's either fine or coarse, just like the others. In the case of a lot of epoxy manufacturers, and definitely with MAPEI, we use what's called a CQ technology, a coated quartz technology, where we bond the pigment actually to the crystalline quartz particle. And that improves a lot of things. It gives you no opportunity for bleed or for discoloration over time, because it's actually fused to the quartz particle. Specialty additives similar to what we've seen before. Same with pigments and antimicrobial. What's the epoxy industry classification? It's 118.3. 118.5 also applies, and the RG is for reactive grout resin, reactive resin, grout. The two grades are non-industrial, industrial. In the case of these graphics here, the Carepoxy IAGCQ is our industrial grade. That's used in commercial kitchens, back of house restaurant applications, be breweries, a number of different things that typically the situation with those installations where you need an industrial grade epoxy is when you have enzymatic cleaners that are like no rinse that people leave over the janitorial leave overnight on the surface, and that in combination with what's referred to as oleatic or fatty acids. That combination of those two things together, which is quite common in breweries and commercial kitchens, etc., that deteriorates normal non-industrial grade grout. So you need to have the industrial grade grout for that reason. Epoxy grouts are impervious, less than 0.1% water absorption. The curing is a chemical reaction between the resin and the hardener. And there's very few installation variables. There are a few that you have to be careful of, and because there is a tendency for epoxy grouts to have a lot of haze film. So we typically grout epoxy grouts with water as its friend, and use quite a lot of water during the washing process to ensure that we minimize the haze film residue. There is a health risk to some people. The numbers I've seen on some studies is less than 2% of men and 1% of women. It's very, very low percentage out of 100 have an allergic reaction to epoxy, but it can happen. So that's something to be aware of. What's the right grout for your tile installation? How do we go about that? What are some of the differences between the different grout categories? We'll look at that first to define that difference. There's several, but we'll talk specifically about mixing step, about product application step in terms of when you're applying the grout, and then manufacturer to manufacturer variations. So just looking at the mixing step first, if you look at cementitious grouts, you have the addition of water, where you don't do that with RTUs. It's ready to go. There's no water to be added. Water can become a variable if it's not weighed. So the mixing step's quite different between cementitious and RTU. You get into epoxy grouts, and it's not a water to be added, but it's the making sure that you get all the components out of the part A and part B in the packaging, and ensure, and possibly part C, and make sure they're homogeneously mixed before you start the grouting process. The product application is quite different too. If you look at cement versus RTU and epoxy, the one that sticks out the most in terms of its difference is RTU. We do, and I mentioned this previously, is a wash as you go approach, where we float probably 10 to 15 square foot. That's our recommendation. Depends on the installer and the conditions. But then come back and do a wash within 10 minutes or less of starting your floating process. And that's about how far someone can get, is about 10 to 15 square foot, or maybe a little bit more than that. Some grouters can go up to 30 square foot in a 10-minute time frame. But you want to make sure you come back and do a wash as you go approach with that. The cement and epoxies are sort of similar, but they're not quite. Cement grouts, we typically don't want to, water is not your friend. We don't want to put too much wash water when we're cleaning, that's for sure. But you float a larger area, and then you use a no transfer of the grout to your finger approach to when you, it's a qualitative approach, but when you want to actually proceed with washing, when there's no transfer. And that can vary. It varies, depending on the grouting conditions, can be up to an hour or slightly more. But it could be less, again, depending on the tile temperature and the air temperature and what have you. The epoxy grouts are, you have a 1 hour window, typically, once you mix the part A and part B and possibly C. Once you get that blend of that epoxy going and the hardener working with the resin, you have about an hour of working time. So you definitely don't want to float more than 30 minutes before you start the washing process. So that's something that has to be looked at. It's really dependent upon the installation conditions. Manufacturer variation. The picture on the right shows what we face out there. I mean, for sure, raw materials vary. We have to fight this even from plant to plant, geographically within the North America continent. I mean, the sand in San Bernardino is quite different than the sand in New Jersey, as an example. The same goes for calcium carbonate. So that's one of the variables. And then, of course, the manufacturers all do their own individual tweaking of the formulations to achieve, you know, desired results we're looking for. Common mistakes made. The first and foremost is probably basing your grout selection on cost and not on need. That's a biggie, and we see that all the time. You really need to ask yourself about the installation environment before you purchase and match it up to that. And that's what, for instance, is it a floor or a wall? Is it interior or exterior? You want to look at all those. Is it going to be a drier, wet, or hot exterior installation area? Is it going to be submerged, or is it going to be no water exposure, or possibly in a shower with intermittent water exposure on the floor? Stain and chemical resistance, is that important to you? You know, you have to ask that question. And then care and maintenance costs. So not considering what kind of tile is being used is also a common error, we say. Glass and porcelain versus natural stone really have probably their niche grout that they should be used in each one of those applications or tile types. Square foot difference on grouts, pretty interesting to look at. Again, if you compare row 3, which is at 40 versus row 1 of the grouts, which is the Portland cement sanded versus high performance cement, you get that $30 disparity per 1,000 square foot, or $3 or 3 cents per square foot. So it's not prohibitive to get that upgrade. You see the slight difference in between sanded and unsanded, and these are typical retail prices. It's not fixed, but it's supposed to represent typical retail pricing. As you move up the ladder, you get into the ready to use, and now you got your full chemical and stain resistance, as we talked about before, with the RTU grouts, as well as with the epoxies and non-industrial grades. So the pricing goes up and up exponentially depending on the grout you select. So what are the variables out there? Not just in extreme grouting temperatures, but also at room temperature. You can have these same variables. The pictures are nice to look at. It gives you a visual of effervescence with that white precipitate we defined earlier. Discolored, shaded, or mottled grout, by far it's the #1 complaint we get, for sure. Just discoloration. You see graphically how that's displayed in the second graphic. Soft or cracking grout can happen by underwatering or overwatering during either the mixing process for cementitious grouts or the cleaning process for any of those grouts. So that's something that distorts the ratio of cement to water. If you play with that, that can cause issues with the W to C ratio. Can cause issues with performance properties. All those can be compromised compressive strength, tensile, flexural, or bond strength. There is a 15-degree rule out there if you do any hot weather grouting, or for home builder market, we deal with that market a lot. I mean, the traditional manufacturers recommended range of temperature for grouting is 50 to 95 F. For every 15 degrees above 70, epoxy, where cement grouts for sure, epoxy is a little bit less than that, but cement grouts lose at least 40 to 50% of the working time. So as a good example is like the 85-degree bullet there. If your working time's 30 minutes at 85 degrees, that's going to go down to 15 minutes. And you need to adjust your grouting accordingly to that because you can get that skin over quicker on the face of the tile, and you won't get transfer quite early with cementitious grouts to your finger. The other extreme is true. If you go down in temperature, you have actually an increase in working time, or time for cure, I should say. Tile industry standards. We defined these acronyms earlier. The ANSI and ISO set the specs for grout. The first one, 118.3, the second one, 118.6, and the third one, 118.7, the fourth one, 118.7, are the 3 critical ones we use. You very rarely see 118.5 and 118.8. Definitely not 118.8 that often anymore. 118.8 was a modified epoxy emulsion. That was the industry's effort to take a OPC grout or cementitious grout and add an epoxy hardener to it to see if they could improve chemical resistance. It didn't go so well. It never was really accepted in the market. I haven't heard any good things about that chemistry at all. Furan grouts under 0.5 are pretty obsolete too. That's based on a different chemistry than epoxies. It's similar, but it's based on what's called a high alcohol chain chemistry, and it uses an acidic compound for the cure for the hardener, not like a traditional epoxy. But it's a two-part system though. So wooden layer Portland cement, we talked about that. That's the different ones before. That's 118.6, and the ISO specs below are the suffixes we saw earlier. And again, I'll mention out that the RTUs is not listed up above because we're waiting for an industry specification on that product. Just quickly to point out some of the TDS data on our 118.6 cementitious grouts, our Caracolor line. With ordinarily Portland cements, the two circled areas are probably the thing we'll focus on. You have a water absorption of less than 10% for a standard Portland cement grout and a Flexural 500. If you look at the high performance, which is 118.7, now our water absorption's less than 5% with double the Flexural strength. So there's a big shift between 118.6, 118.7 as it applies to water absorption, Flexural strength. But the key focus there is water absorption. It's a huge difference in water absorption. And looking at 118.7, which we just did, going on to RTU grouts, the key thing here is probably its extensive list of chemical resistance results, all passing. And these are not easy acids, et cetera, sulfamic acid, hydrochloric acid, sulfuric acid, that it's passing after 28 days of exposure or immersion. And that's making a test sample and just dropping it into these various chemicals. So it's very impressive, and it's similar, it's not identical to what we see with epoxies. The other thing to point out there is that we do pass, and that's why we use some of the epoxy and also some of the cement specs with 118.3 and 118.6 for RTUs, pending their own spec. 118.3 and ISO, the key things to point out here is now our water absorption's down to 1% or less. Impressive. It's obviously our most robust grout and our Cadillac in terms, as you see in price point as well. But you see the Flexural and compressive are extremely high. Personally, my favorite is probably the epoxies for a lot of different applications. There's another classification system referred to as COM and RES, or environmental classifications. The COM is for commercial installations and the RES is for residential installations. And what this does is just define various job site conditions from COM 1 through COM 7, RES 1 through RES 7. And what the grout manufacturers do is market this, and put it on our bags where we pass COM 1 through COM 5, or COM 1 through, or RES 1 through RES 5, or whatever the case may be, depending on the grout category. So it's another differentiator as to what grout's appropriate for your application. This was first introduced to system environmental classifications in 2012, or I think 2012 or 2013. So it's been out for about 8 years or so. It's grown in the last couple of years. The COM 7 was added, I think, in 2018, 2019, which is the immersion status. So look for this on the grouts as you purchase too, because it's a great tool for picking the right grout for the application or the installation type. Caulks and sealants. So switching gears, MAPEI's two product offerings are siliconized acrylic and of course 100% solids, 100% silicone sealant. So we have our two products that we offer there. The different chemistries out there in terms of the glue or the emulsion polymer used to make caulks. The vinyl acrylic was the first generation. It's sort of it's almost a painter's caulk, latex caulk that you hear about. It's very just for filling nail holes or whatever like that. It's not a high-end caulk. The second one, the 100% acrylic, is pretty much the siliconized acrylic caulk that I mentioned before. That's that technology. So it's a higher version of the traditional latex acrylic. The urethane and silicone. Some people use a urethane. We don't offer, at least in my group, in different departments we have at different business units. We offer a urethane sealant, but we stay with two chemistries in terms of tile and stone. We stay with a silicone, 100% silicone, and with the siliconized acrylic. Hybrid chemistry is something MAPEI is pursuing now a little bit. It's referred to as MS polymer or modified silicone. It's a next generation version of silicone that's actually paintable, so it has that advantage to it. Fillers, calcium carbonate's typically the standard filler with caulks, and then of course they have the things we saw in pigments too: antimicrobials, surfactants, cross-linkers, and in some cases, but not all cases, they have plasticizers. Not all of them. Our siliconized acrylic is in the graphic there. It's a Caulk product. The interesting thing about comparing siliconized acrylic to 100% silicone is how it cures. I mean, what you see here is our siliconized acrylic, their Caulk, and it dries as the water evaporates. So actually, if you put a fan in the room, you'd be better off. But in the case of silicone, it needs moisture to dry and cure. So if you want to do anything, put a humidifier in the room to enhance cure. It's referred to as room temperature vulcanization with silicones, or RTV. And in the case of silicones, or excuse me, siliconized acrylic can be painted where silicone cannot. So that's important to note. That's sort of one of the things you make a decision on. In the case of MAPEI, where every grout color we have a caulk, and that's a complementary product to our grouts. So that's why we offer that, of course. So you don't really need to paint in that respect. Acrylic caulks are water-based, so they're not fully waterproof for that reason alone. So definitely don't recommend them probably in a shower install or a sink surround or whatever. Not the best choice for exteriors. Obviously, they crack and shrink as well. If we look at 100% silicone, there's 4 different cross-linkers that are used, or categories. There's acidic, alkoxy, oxime, which is what we use for the MAPEIUSA plus, which you see in the graphic, and then the MS polymer. It dries to a joint movement. It can range. It's a rubbery texture, but the joint movement can range from plus or minus 15 all the way to plus or minus 50. We use a plus or minus 25, but in some applications, like in the California market, the plus or minus 50 is mandated because of the earthquake zone that exists in. Greater flexibility and elongation is typical with this rubbery texture. So you see that with the that testing at 410%. It's freeze-thaw stable, and it's preferred product for wet environments, as I just mentioned. And the surface temperature is really large there. It's minus 60 F to 400 F. So the surface temperature is very impressive with this versus a siliconized acrylic. It cannot be painted though, and it is somewhat difficult to tool at times, depending on your technique. EGA 171 is sort of the industry standard set by TCNA for movement joints. You can get a kick out of that graphic where these guys set this tile. Looks much better without all those ugly expansion joints. They set that tile without an expansion joint, and they got tinting, and that's what they're showing in that graphic. So there's set distances that require expansion joint in between the grout joints that compensates for expansion and contraction. For interior, it's 20 to 25 feet. For if it's interior with daylight, or excuse me, direct sunlight, then it drops to half of that. Exterior is 8 to 12 in each direction. And movement joints are required for both interior and exterior change of planes as well. That's the EJ 171 spec. Selecting the right grout caulk for your installation. I think we've all saw this before at big box. It's overwhelming when you look at that graphic and see in the paint aisle, this is the paint department of any big box, the magnitude of different caulks and sealants that are on the shelf. and they all have their special need and function and how they're formulated accordingly. In the case of grouts or the tile oil, as we like to call it in retail, and there's really just two types that cover the gamut of what we need in a fluorine type installation. That's either siliconized acrylic, latex, or 100% silicone, and that's what we offer. How do you select the right grout for the job? I mean, you want to make sure you have the right tool to do the job. So what's some key questions? What's the temperature range requirement? I showed you before how silicone's got a broad range of temperature, surface temperature range. And then is waterproof requirement? You definitely want to go with a silicone if there's a waterproof requirement and not latex. Will the caulk need to be painted? Well, we can't paint silicone, but you would look at a siliconized acrylic, or you would go to an MS polymer type of formula. What level of reliability, or urethane, that's another option, I guess. What level of reliability is required? You know, you're concerned about the longevity over time. I mean, some 100% silicone sealants can go up to 20 years of installation before deterioration. Shrinkage and cracking is important. So you look down for the list here, you got, you know, the traditional window panes, which we suggest are urethane. The roofing, which is more of an elastomeric or a rubberized product in terms of filling the gaps. Interior trim was one I mentioned before, like the painter's caulk, filling nail holes and that type of thing. And then kitchen and bath, we definitely recommend a silicone. And of course, for expansion joints and perimeter joints, based on EGA 171, it requires a silicone with a traffic grade rating of 25 Shore A or harder at 24 hours. Tile and stone care and maintenance solutions. Typically, the manufacturers offer 3 different categories, and that's what we do on our line here. We have sealers, finishes, cleaners, and problem solvers. These are for, again, for the natural stone, tile, and grout that's used for. Natural stone probably gets the most play, definitely with the sealers, because it's very important to seal some of the natural stones on the market. When you're talking about the softer marbles and limestones, which are more sensitive or more porous and exposed than versus a quartz countertop, which would be in some cases not even requiring a sealer. Depends on the manufacturer's recommendations. But sealers start with topical, penetrating, and enhancing. Those are the 3 categories. You have to ask, well, in our case, we have both aqueous or water-based and solvent-based penetrating sealers in our line. And then there's 5 chemistries to consider. And they all have the basic differentiation. You'll see it on the next slide. Between these chemistries is their molecule size. So the smaller molecule are typically, in the case of the fluoropolymer, it's called a nano molecule. These are appropriate for dense stone, where you want, even porcelain in some cases, where you want to seal it, but definitely the denser natural stones, you definitely want to go with a fluoropolymer type of chemistry, and possibly a solvent base, which would be more appropriate for a dense stone. Water-based, oil-based, or in some cases, water and oil stain resistant. The fluoropolymer chemistry is water and oil, and that's sort of like the newer trending technology right now from a chemistry standpoint. How do you check the efficacy of a sealer? Well, you just do a water bead, just pour some water, drop some water droplets onto the surface and see if it beads. The better the bead, the more protected that surface is with a sealer. If it's not beading at all, you obviously need to apply a sealer to it. Finishes are topical, so we're switching from penetrating to topical. They come in a low sheen and a high gloss. Cleaners are broken up into 3 categories. I showed 2 here. Either low pH or high pH. There's a 3rd one, and that's what we call a neutral pH cleaner. So it depends on the type of stain. There's a slide coming up on that. I'll show you that real shortly. And then problem solvers. Haze film, as I mentioned, is probably you know, one of the key issues we have with epoxy grouts, and also sometimes RTU grouts in terms of haze residue. Real quickly, the chemistry of stones and tile, just breaking down the 6 different categories. As I mentioned before, it's really all about the molecule size. The silicates have a very small molecule. That's the potassium, lithium, or sodium silicates. It's sort of it was first generation chemistry, in my opinion. Even it's still out there to a certain degree. Silanes, sort of again first generation, but has a small molecule. Siliconates, we definitely utilize this chemistry as well as the siloxanes in our Ultra Care line. It depends on the application and where we would promote one or the other. And we don't refer to them as siliconates and as fluorocarbons or any of those categories. We simply call them what they are. I mean, if there's for a certain application like water-based, we refer to it as a 10 plus sealer. We don't really call out the chemistry. In some cases, you can pick some of that up in the SDS and chemical composition sections 3 of the SDS, but we don't typically promote that. There's some exceptions because fluoropolymers are getting so popular now. We definitely try to promote that or market that, and it is oil and water resistant, so it has a lot of advantages as well. And the way that we break up soiling, and you see in the picture how much a difference a cleaner can make, is whether it's inorganic soils or organic soils. So, I mean, the traditional inorganic soils are rust, lime, hard water deposits in a bath or shower, effervescence, which we all know with grouting that occurs. So, and we have our effervescence cleaner as a problem solver. So these are all addressed from an acidic type of cleaner, which is a very low pH, typically below 2 on the pH or below 2 and 3 on the pH. So it's a very acidic type of formulation. If you have more of an organic stain, which like fat, greases, or mold, bacteria, something like that, you're looking at using a high pH cleaner, something typically above 10 on the pH scale to remove organic staining or soils. Pay attention to the pH scale, it's important. It can be, what happens most is with natural stones that are porous or sensitive. Marble and limestone are great examples. You take a lemon juice or a vinegar at 2 pH, and you're looking at having acid etching, and penetrating sealers won't save you from that. I mean, it literally will go ahead and etch it if it's left to dwell for a period of time. So that's a big issue. I just saw an ad the other day on an infomercial where vinegar is typically sold around 5%, I think, on concentration. They're advertising a 30% vinegar product for household cleaning. So think about that in terms of acid etching on a marble or limestone countertop. High pH household bleaches are commonly used. Ammonia are commonly DIY cleaning approaches for stains. So you got to be careful about using that stuff direct without dilution. Or using a dedicated care and maintenance type cleaner, which is not the mercy of these household products. And you can see the range of pHs on some common stuff there with coffee and soda. So let's review. Going through on the end a little again, tile grouts, they serve both an aesthetic as well as a practical function. We talked about all those in terms of how it's used. Caulks and sealants fill and seal grouts, but just as important, they're used for movement joints and perimeter joints in tile installations. Care and maintenance products actually preserve the longevity of your tile and stone installation. That is obviously very important with the investment we have with flooring. And so just a shout out our challenge to each of you. I mean, on the DIYer level, who's listening in here, I would definitely challenge you to follow these guidelines and look to ensure that your product was installed properly and that you'll have a end result to your expectations. And for the professional, I mean, they're already following ANSI ISO specs and standards, which is going to lead to more satisfied customers, better referrals, more money in your pocket. And I guess in today's market with their inflation, it'd be nice for all of us to have more money in our pocket. But that's the overview. Appreciate your time.
Thanks, David. We have some questions for you.
Okay, great.
So let's see here. The first one, will an RTU take a penetrating sealer?
Yeah, it will, but it's not necessary. I mean, you saw the chemical composition we had that we showed you there was essentially like an epoxy, but it can be sealed. It will take it will bond to it, but we don't market it because of lack of necessity.
Yeah, exactly. Okay. So, the next one. Which sealant can be used for repair in case of damp surfaces?
Yeah, I mean, I would definitely go with silicone. I mean, the issue with acrylic latex sealants or caulkings is that they're water-based to begin with. They're not 100%, and so they're not waterproof because they're water-based. So
Yeah,
I wouldn't want to use. I would definitely go 100% silicone in that application, or an MS polymer approach for formulating it, or for installing it.
yeah, exactly. Okay, here's another. What grout would you recommend for a commercial installation that's going to be seeing heavy foot traffic?
Okay. I mean, for me, the first thing that comes to my mind is probably the RTU, or RTU grout, or an epoxy grout, simply because you mentioned heavy foot traffic, and that's always going to lead to soiling and staining, and your epoxy and your RTU grouts are going to be more robust to handle that over time in that heavy foot traffic. I mean, you could go with a cementitious high performance as long as you add a sealer to it to help longevity of the grout in terms of cleaning maintenance.
Gotcha. Well, give everybody a few more minutes here.
Okay.
Um, Here's another. What is the best care and maintenance tile and grout sealer for my marble countertop glass tile backsplash? Marble and glass together there.
Okay. Well, for marble, I mean, like we talked about, I would definitely probably a water base would be fine. It's porous enough that the water base is going to get into it and penetrate it. So I would go for a high performance pin sealer for that, what we call our penetrating plus for that. And what was the other part of that? Was a glass
The
backsplash.
glass backsplash, yeah.
That's
Yeah.
right. Glass backsplash. I would probably, for that, in terms of the sealer, the glass itself doesn't require sealing, but I would probably go with whatever grout that's being used on that backsplash to use the appropriate sealer for it. I mean, depending on the grout, I guess is what I'm trying to say. If it's
Exactly.
epoxy grout, you wouldn't require
Yep.
sealing. Ready to use grout wouldn't require sealing. But if you did a cementitious or a cementitious backsplash, I would definitely probably seal that with. I would go with more of a. You could go either way. You could go to an aqueous or a solvent-based sealer, but a penetrating sealer.
Gotcha. That's good. Oh, interesting. What would you recommend for, say, a terrazzo area?
In terms of grout or
Ceiling, sorry, the
sealing,
best.
I'm sorry. I'm sorry.
Yes, here we
So
go.
for sealants specifically,
Yeah.
you know, I- I would probably go with one of our CRS products for sealing. I don't know that we really promote our tile and stone for terrazzo. I'd have to double check on that. But I know in our concrete restoration business unit, they're more
That's right.
focused on that flooring type, and I think they have some dedicated sealers for terrazzo.
Yep,
It's
absolutely.
probably I wouldn't guess at the chemistry, but that's probably the direction you'd go.
Head that way. That sounds good. Um, all right. Well, David, thank you so much for a very, very informative presentation. And I see there's a question, will we be sharing it? Absolutely. All of our webinars are actually online. You can go and visit www.mapei.com, and in our technical services pages, you can find them there, or you can also go to our YouTube channel and search for the webinars that way. So lots of different ways to find them, but they're always, right there. It takes about 2 to 3 weeks. We have a little bit of a backlog, but it'll be there. And we want to thank you for joining us today. because we know, you have very busy schedules, and we do appreciate the fact that you've chosen to spend some time with us. And David, thank you again for sharing all of this information with us. We do appreciate it.
Thank you, Jennifer.
So, yeah, thank you. Until next time, everybody. Thank you. Bye-bye.